Hello everyone, my name is Seyfun, and in this assembly code we will create a program that calculates and prints both the area and circumference of a circle using separate functions. After this lecture you will gain a deeper understanding of use of local variables and functions and floating point calculations and the formatted output printing using the printf function. So now let's create this code step by step. First let's close this. Now SASM, I will open the SASM here and create a new project, delete this, save this on the second function project. Yeah, we are here. Let's name it second function project, open second function dot second second function dot asm, and that's it. Save it here. That's it. Now we will first declare external function printf here. So extern printf, and after that we will create a section data. And this is in this lecture you will also learn the local variable here, and I will explain this further in this lecture. And now in this section data we will have the radius here. This is going to dq 10.0. Here we are declaring the circle as a double precision. So here we are declaring the radius of the circle as a double precision floating point number, and after that we will create a section text where our real code will reside here, and after that we will develop the area calculation function here. So area here and section data. So this is a local variable, and I will explain this further. So P here, dq, and 3.141592, I think, yes, 65 and 4. So this is a local variable to the area function, and we will also create a section text again. So pash rbp, which is for the saving the base pointer. We will set up the base pointer here, move rbp rsp, and now we will load the radius into xmm0 here, xmm0 and radius, and we will use the move. No, we have to use the move st here, and move st xmm0 radius again, move radius. Here we are multiplying xmm0 by the radius to calculate the squared radius here, and after that we will use mul st again, mul st xmm0, and we will use the dot p, which is for multiplying the xmm0 by the local variable p here, and after that we will just write leave and write. With this we are restoring the stack frame, and with this we are returning from the area function. And now we will use the circumference calculation function. So we will do circum here, or circumference here, yeah, circumference section data again dot p dq here 3.14. With this we are defining the local variable to the circumference function. So we will also develop the text here, pash rbp, which for this we are saving the base pointer, and now we will set up the base pointer here, rbp rsp, move st xmm0 radius. Here we are loading the radius into xmm0, add st xmm0 here. With this we need radius. With this we will add xmm0 to itself to calculate the diameter radius here, and now we'll mul st. With this we will multiply xmm0 by the local variable p here. So xmm0 p here. So I think it will be more nice to add tabs between this. and after that we will leave and ret. So with this we are restoring the stack frame, and after that we are returning from the circumference function. Now we will need to also define a circle for circle calculation and printing function. Now here we will go to circle. Here we will first create a section data and fmt area format area here db, and here db, and here the area is f here, but lowercase f here, and 10 0. With this we are format string for area here, and now format circumference here db, and the area is f, and now we will the circumference is f, and that's it. 10 0 0. This is format string for the circumference. After that we will define the text section text. We will push the rbp, which is for saving the base pointer. We will set up the base pointer again, rbp rsp, call area here for calling this area function, and after that area, and after that we will move rdi. Actually we need to add tabs here. So we will load the format string for area. So in order to do that, format area here, and after that, so we called the area function, we loaded the format string for area, and now we will load the area into rack. So move rax1, and we will call the printf to print the area, and now we will call the circumference for calling with this we are calling the circumference function. And actually let's check if is there any typo. No, perfect. And after that, so we called the printf, we called the circumference, so we will move the rdi format circumference. Here we are loading the format string for circumference, move rax1. With this we are loading the circumference into rax, and now we will call printf. With this we are calling printf to print circumference, and now we will leave. With this we are restoring the stack frame ret return from the circle function, and now we just have to declare the entry point of the program, and we are done with this code. Now global main here, with this we are declaring the entry point of the program as main, and main here, and the push main, yeah, global main, and with this we will first push save the pointer, save the base pointer, which is rbp, move rbp rsp. With this we are setting up the base pointer, and now we will call the circle. With this we are calling the circle function. We'll leave and ret. With this we are restoring the stack frame and returning from the main function. So that's it with our code here. Now what we're gonna do is let's actually check this here, and as you can see it's working perfectly. So the array is this, and the circumference is 62.8000. So 62.8 here. Now I wanna explain this code as we always do. So here the code defines three functions: area here, circumference, and circle. So the area function calculates the area of the circle using the formula P here. Let's actually open the formula here. So I know some of you don't like mathematics. I don't like it either, but it won't be just it's a simple formula here. So p multiply radius and multiply radius. So here the area function calculates the area of the circle using this formula, and it uses a local let's actually go to area. So it uses a local variable p specific to the area function, as you can see here. So we have defined two variables, but they actually is pretty different things here. So they are completely different, and they hold different values here. And the circumfunction here, so circumference function of the circle of the using, let's actually open this here. So this is for the area, and now with circumference we will multiply 2p here. No, yeah, 2p radius. Here, the circumference function calculates the circumference of the circle using the formula 2 multiplied by p multiply radius. So it uses a local variable p specific to this circumference function, and the circle function calls both the area here, area and circumfunctions, and prints their results using the printf. So that's why we just called this circle, and it did all the work for us. And in the main function, as you can see, the code calls circle function to calculate and print the area of the circumference of the circle. And the code demonstrates the use of local variables within functions, highlights their encapsulation and their specific scope within each function. So this code showcases modular programming with separate functions, the use of local variables, and floating point calculations in assembly language. So it emphasizes the practice of breaking down a problem into smaller functions, improving code readability, maintainability, and reusability. So now, as we always do, let's go through this assembly code line by line, explaining each steps in detail, because there's some new things here, like the local variables, mul_sts, the add_sts, and so on, which we used it first time. So here let's go from 0, right? So this line declares the printf function as external, which means that the function is defined in another module, typically a library, and will be linked at compile or link time. And here the section data radius dq 10.0. With this we are declaring the radius of the circle as a double precision floating point number. And this section declares the data section where the initialized data is stored. So the radius variable is defined and initialized with a double precision floating point value of 10.0, representing the radius of the circle. Now in this here section text, the line defines the text section where the program executable code is located. And here the area, this line defines the start of the area function, which calculates the area of the circle. And section data, p here, p value. So within this area function, the section declares a local variable named p, which is specific to the area function. And it is initialized with the value of p, approximated to high precision here, as you can see. And now we have the section text, push RBP, move RBP, RSP. So this sequence of instructions sets up a stack frame for the area function, and it saves the base pointer on the stack and then sets the base pointer to the current stack pointer. And after that we have move xmm0 radius. With this we are loading the radius into xmm0. So this instruction loads the value of radius variable, which is 10.0, from memory into the xmm0 register. So xmm0 is a 64-bit SSE, so streaming SIMD extension, SSE register capable of holding a double precision floating point value, which you will learn these SSE registers in next lectures, and in deeper, of course. So this is just a brief explanation of SSE registers. So, and here MUL_ST XMM0 radius. With this, we are multiplying XMM0 by the radius to calculate the squared radius here. So this instruction multiplies XMM register, which holds the radius, by the value of the radius variable again, effectively squaring the radius. And here we have the MUL_ST XMM0p. With this, we are multiplying XMM0 by the local variable .p here, and this dot means that it's local. And this instruction here multiplies XMM register by the value of the local variable p, resulting in calculation of the area of the circle. And after that, we have leave and read. With this, these instructions are used to clean up the stack frame and return from the area function. And we have circumference here. Let's go down. So here the circumference, this line defines the start of the circumference function, which calculates the circumference of the circle. So we have with section data and PDQ 3.14. This is a local variable to the circum function here. So similar to the area function, the circumference function defines a local variable named p with a value of 3.14 specific to the circumference function. And then after that, we have section text here. Let's actually now. So the section text here, we are first saving the base pointer, and after that we are setting up the base pointer here. So this instruction these instructions establish a stack frame for the circumference function, saving the base pointer and setting it to the current stack pointer. And after that, we have MOV_ST XMM0 radius, add_ST XMM0 radius. So this MOV_ST XMM0 radius here, with this we are loading the radius into XMM0 register. So this instruction leads to the value of the radius variable into the XMM register. And after that, we have the add_ST here. This instruction adds the value of XMM0, which is radius, to itself, effectively calculating the diameter of the circle. And we have the MUL_ST here. With this, we are multiplying XMM0 by the local variable p. So this instruction multiplies XMM0 by the value of the local variable p, resulting in calculation of the circumference of the circle. And we have leave and read. These instructions clean up the stack frame and return from the circumference function. And after that, we have circle and global main. So this line here defines the start of the circle function, which calls both the area and circum functions and prints their results. And section data here, the area is f, the circumference is f here. So this section defines format strings to be used for printing the calculated area and circumference values. So f is a format specifier for floating point values, and 10 and 0 represents the new line character and null terminator. So 10 is the new line character and 0 is null terminator here. And here we have the big chunk of code here, section text. So I explained this here. There's nothing new for us here, but within the circle function, this sequence of instructions calls both the area and circumference functions, calculates their results, loads the appropriate format strings and values into registers, and then calls the printf function and to print the calculated area and circumference values. And after that, we have leave and read as well. So these instructions clean up the stack frame and return from the circle function. And lastly, we have main. So with this global main, we are declaring the entry point of the program as main. So we have the push RBP, move RBP RSP. With this, we are setting up the base pointer. And after that, we call circle. With this, we are calling the circle function, leave read. So the main function starts with saving the base pointer, setting up the base pointer, and then calling the circle function. After that, the stack frame is restored and the program returns from the main function. So this assembly code demonstrates a structured approach to solving a problem involving calculations and formatted output. So it showcases the use of function with local variables, stack frame management, and function calls. So the code is designed to calculate and print both the area and circumference of circle, emphasizing modularity and readability in assembly programming.